one actually with the density function is c times x squared, and this x is from 0 to 1. Okay, and I want to first find c, this constant, and the second one is figure out a way to generate x. So anyone try to do this at home? Maybe not. It's okay. So let's see. How can we try to do that? So first step, we need to find c. So what does our density function mean? This means if you integrate this, of course, on its domain here, it should exactly equal to 1. So this tells us right? And then we plug 1 inside, so which means c over 3 is 1. So c is 3. Is that okay? Is that right?
Yes.
Okay, c is 3. Thank you. All right, thank you. All right, then how should we like generate x? So same thing. We have density function, then we need to find cumulative distribution function. So CDF. We already know C is 3, so I put 3 here. Okay, and then we have, so this is tau cube, plug 0 and x inside. So it will be x cubed. Okay, so we have this is the CDF. And suppose we have Z follows the uniform distribution on the interval 0, 1. Okay, so this is our f of x. So what is f inverse? This one is easy, right? Cubic root. So which means if I have some, so suppose I have a Z1 and Z2. So Z1 is 0.0599, Z2 is 6723. Then I asked you to find x1 and x2. Can you try to get that? So of course it will be easy. So we know we just plug Z1 and Z2 inside. So this should be the cubic root of 0.4599. This is cubic root of 0.76723. Okay, you should calculate this. This is how to do the inverse distribution transformation. Is that okay? This is not so complicated, right?
Yes.
Okay, so the idea is always first find a cumulative distribution function, no matter this case or what we have here. So here, actually, I should mention because they're inverse function, right? So which means they should be symmetric about y is equal to x. So you can see here we have this is f inverse. So they're symmetric about this y is equal to x. So this is the cumulative, this is the original cumulative distribution function. This is inverse of that. So the idea is if you were given some density function, right? You can always first try to find the CDF if you want to do the inverse transformation, this inverse distribution transformation. Find the CDF, and then you try to find the inverse, and then you can try to derive this x based on this uniform random variables here. But if it's discrete, then for the discrete, you still need to do the cumulative distribution, but this time it's a jump function. So like what's similar, where is it? Yeah, like this one. So you still need to know how to map it back, but you can do exactly similar way to draw this line and then you map it back. It will be easy for you to know how to map it back. Okay. All right. Any question regarding this inverse distribution transformation? I think it's not too complicated, but some trick here. If you think this is a little bit complicated, you can consider say, let's just ignore this. Let's just do the regular way. It's also fine. It's correct. It doesn't mean you always need to convert this C to 1 minus C. Okay. All right, so this is one way to generate a random variable. And this helps us, like, even though if we just have the random or just the uniform one, we can know how to generate this, okay? All right, then today we will move to something different. Is acceptance rejection method. So this is another method we try to do.